Welcome students to the fourth lecture of railway engineering. Right. Today we are going to study the what are the aspects that we have to look when we have to select a new alignment of a track. Right. Then we are going to see the forces acting over the track. Right. Which are the various types of forces that act on the track. Right. And also we are going to see about the gradients, types of gradient. Also we are going to study about of the special terms that we are going to use in this railway engineering. Very important terms we are going to see. Right. This lecture is very important, very crucial for the basics of railway engineering. Right. So factors considered while selecting a good alignment. How the route or track should be, in the which direction we are going to move. So how it should be. Right. What factors affect it. The length of the track should be as short as possible. We try to reduce the distance how much we can. It's not that we have to reduce it fully. We can't do that. But how much we can reduce it, try to reduce it. So that is what it is trying to say. The initial construction cost should be minimum. This can be achieved by avoiding loose earth, slopes, rock cuttings, cross drainage by the alignment track on the watersheds. When the track is to be placed, you should see that it should avoid cutting of the earth, right, or deep cuttings, rock cuttings you can say, or slopy earths. So you have to provide, if you are going to go from the slopy earths, then you have to support those slopy earths with the retaining walls, right, all along the length. That will become costly. Right. Cross drainage means bridges, canals that cross your train track should be lesser. So otherwise you have to provide a culverts or bridges for it. But if it is there, so we at some point if it is there, but we cannot change every time, right? Change the direction. And you have to provide means you have to provide in some cases. Maintenance cost should be minimum, right? Maintenance cost should be minimum. It says initial cost should be also 0. The minimum maintenance cost should be also be 0. Maintenance cost can be reduced by avoiding deep cuttings, high banks, long viaducts, heavy gradients, which cause heavy wear of the rails and rolling stocks. What is rolling stock? Hold together the compartments, the wagons you can say, and the engine. All the whole components of train together is called as rolling stock, which will move. Rolling means which will move is called as rolling. It should be have easy gradient so that locomotives can haul. Haul means can cover. Can have energy that can cover more load. Energy that can take more load. And transport charges may be minimum. If easy gradients are provided, hauling capacity is more, then the rate of the transportation will reduce, obviously. It should give maximum safety to the passengers without any chance of accidents or derailment. The place we should be selected such a way that there are less accidents and derailments, right? It should possess important cities and industrial areas. Whenever we are selecting the alignment, it should pass through the important cities and the industrial areas, because those are the where transportation facilities required more. It should pass through the it should possess aesthetic areas. It should pass through the aesthetic areas, and so that the passengers may enjoy the journey. When you are selecting the alignment, it should go through or pass through the alignment should go through the beautiful sceneries, nice areas, right? So that people will enjoy while moving from one place to another place. Next is forces that are acting on the track. We are not talking about the train, we are talking about the track. Rails is subjected to heavy stresses due to the following type of forces. First is the vertical force, consisting of dead dynamic loads, including the effects of the speed of hammer blow effect, the inertia of reciprocating masses. So what it is trying to say is the vertical force that comes from the train during it is static as well as it is in a motion. So that is called as vertical force that is acting over the track. Next is lateral forces. Due to the movement of live loads, eccentric vertical loadings, shunting of locomotives. During this case, what happens? There are lateral forces applied over the track. Right? The longitudinal forces, longitudinal means along the length of the movement of train. Right? When the train tries to move over the track, that time these forces are being applied. Right? We have to overcome the frictional force, we have to come the inertia force. Right? When you apply the brakes also, there are forces applied over the rails or a track, you can say. So these are the all forces that act over the track. Right? Another one is contact stresses due to the wheel and rail contact, because both rail and as well as the wheels of the train are made up of steel. So there will be a friction force generated. Right? Friction will be generated. So that also force will be included on the tracks. Right? Stresses due to the surface defects such as flat spots on the wheels. So if there are due to the wear and tear of the vehicles, of the wheels and the rail, there are chances of stresses to be developed on the surfaces. Now the concept of coning of wheel. See, this term explanation is very important. You might have seen the wheel of the right of the rails. Right? This is how it are actually. Basically it was like this. Now they are different, but for a explanation I will take this. Right? This is how your train wheels are. But when you are right moving on the curve, what happens? This is the inside of the curve, this is the outside of the curve. Right? Whenever I try to negotiate this curve, right, train, the centrifugal force, we have studied this centrifugal force F, we will try to push the train in this direction like this. So what will happen? This is how it happens. Right? And this is what happens. Right? What happens when you're trying to move on the curve? The force is applied here like this. Right? So when the train tries to push the wheels, due to which what happens? There is a wear and tear here. Can you see here this side? So to avoid this and to bring the, if this happens and the force is more, then this wheel may get outside of the track, so derailment may occur. So what we do is we try to maintain this wheel inside. So how we can do that? What we do is whenever we are negotiating on the curve, right, the distance covered in the inner curve is lesser than the outer curve. What I'm telling you, are understanding? The distance if you measure here from here to here and from here to here, this will be more. If this is your curve, right, the distance if you measure from here to here and in the outer curve, and this is more, this will be greater than this, be lesser. So what they did was to overcome this derailment and to overcome the to maintain the equilibrium conditions, right? What they did, they provided some slope to this wheels like this, right? They provided some slope. This is how it is provided, right? So that what happens when the train is moving over the curve, right? When it moves outside, right, the because of the it is trying to push outside and the length is more, it will easily balance the body weight of the wheels and it will cover the area like this, over this. But this comes over the with the experience and the experiment they decided, so that there should not be any frictions. So this providing a slope to the wheels, right, and this slope is how much? This slope is 1 in 20. How much it is? It is 1 in 20. So this the slope which you provide is called as coning of wheels. What it is called as? It is called as coning of wheels, right? The slope that we provide to the wheels, right, so that it balances itself over the curve and it maintains its equilibrium condition. So for that case we provide a coning, right? Can you see this? Can you see this slope that is provided here, right? So that it maintains the equilibrium, right? So that it maintains the equilibrium. The art of providing an outward slope of 1 in 20 to the threads, because if you see this, this is called flange, right? This is called as flange, right? And this is called as thread. It is called as thread. So to providing an outward slope to the threads of 1 in 20 is called as coning of wheels. On the straight portion of track, if the axle moves towards the one track, the rail of the diameter of the wheel rim over that of rail increasing, whereas decreasing in the opposite directions. Means what? When you are moving in the straight, in this case, and you're moving on this straight road, due to the some lateral movements, what happens? Your train tries to move here or here in the lateral directions. So when that happens, what happens? There is a wear and tear of the rail and the flange. So to avoid that, to maintain the balance of the wheels of the rail, what we do, we provide some slope so that it maintains its balance, so it doesn't move outside and inside, right? So that we reduce the wear and tear of the wheel and the flange of the wheel and the rail, right? Gives a smooth riding. It's helped the vehicles to negotiate a curve smoothly, right? It reduces the wear and tear of the wheel flange. Now we know that we are going to provide coning, so that whenever we are negotiating a curve or when there is a lot of lateral disturbances, to maintain the gap between the rail flange and the rail wheel, right? Wheel flange and the rail, we are going to provide the slope, right? We are going to provide a slope like this. Right, this is what was a slope they are going to provide. So when you are going to provide and if you provide a straight rail like this, what would happen? The contact between the rail and the wheel will be lesser. So due to that, what happens? The contact is less, so the friction at that point, wear and tear will be more, and it will not balance properly. Balancing of the wheel will not be happen. Balancing will not happen. So for that, what we do? For that, what we do? We will tilt the rails now. We have provided a slope to the wheels. Now same thing, we will be providing the slope like this on the rails, the sleepers. Over the slope that is provided on the sleepers, same we will be providing like this. This is what is slope. And you see this inclined shape that is provided, so that the surface area is more between the and the balance, and there is a stability between the rail and the wheel. So for that we tilt the rails. So how we tilt the rails? The tilt slope that is provided itself on the slippers. You have to just place this rails over it, so that it automatically takes the slope of slippers. Right? What slope we provide? We provide the same slope, that is 1 in 20. Right? When you tilt the rails like this, is called a tilting of rails. TILTING. Right? Tilting. And when we provide the slope to the wheels to overcome the curves and the lateral disturbance, is called as coning of wheels. Right? Both are of slope 1 in 20. In order to minimize the disadvantages caused by the coning of wheels, the rails is tilted inwards at an angle of 1 in 20. This reduces the wear and tear of the rails as well as of the thread, because as I showed you why that happens, right? Because the contact area between the rail and the wheel will be lesser. So in that case, what happens? Reduce that, the disadvantage of coning, we tilt the rails with the help of the sleepers. The main objective of the tilting of rails is to reduce the wear and tear on the rails as well as the thread of the wheel. The main objective of tilting of rails is to reduce wear of the edge of the rail in the track, the edge of the track, as I showed in the figure, last figure.